if you make 5 assumptions about the same things, these assumptions are different, then you're on the edge of what people can understand. On the other hand, if you write a computer program to do something, and it has 100 lines of code, then we don't have any way to figure out the consequences of that in general. It's just too hard. And it seems to me that the reason why psychology didn't get anywhere until starting around the 1950s was that in the appearance of what we now call computer science, several hundred new ideas appeared that no one had ever had. So very often people think of computer science as the science of what computers do. And I think of it as quite different. Computer science is a new way to describe and think about complicated systems, and it comes with a huge library of new ideas. For example, sometimes I hear brain people saying, well, it looks like memory is located in the hippocampus. And then another one says it's not located in the hippocampus, it's only stored there for a little while, and then somehow it's moved into somewhere in the cortex, other cortex. The hippocampus has 4 or 5 cortexes of its own. And they talk about working memory and long-term memory and short-term memory. If you buy a computer today, you know that it has a big memory that's slow, it's called hard disk or tape or whatever. Then it has another memory that's pretty fast called RAM. Maybe it has 1 million words of that fast memory, or 50 million now, since it only costs a few cents per megabyte. The average computer also has something called cache for instructions, where it remembers the last few things it did in case it needs them to do again. Then it doesn't have to go and look somewhere else for them. It's got several kinds of cache. It has front-end cache and back-end cache, and I don't remember what those are. But the point is that in computer science, there are ideas about dozens of kinds of memory. There are dozens of kinds of ways things can be stored in memory. You can store them as if-then rules. If this happens, do that. You can store them as things called semantic networks, which are little pieces of information connected by links that themselves have properties. You can store things in what are called neural networks, which are like semantic nets, except that the links are dumb. This is connected to this one by a link that has some number like 0.7. Neural nets are wonderful for learning certain things, but they're terrible for the rest of the machine, because the rest of the machine can't figure out what the neural net knows. So some years ago, Papert and I wrote a book about the limitations of neural nets, but we didn't talk about the really serious limitation, which is that the more of the brain that is used to learn in that particular way, the less the brain will be able to think and reason about what it's learned. So one thing that we've learned in artificial intelligence or computer science is that there's some fast tricks which are sort of effective and useful, but in the long run they're dead ends, because the machine doesn't understand what it knows.